Good morning students. In this class, I will be doing class 9 Samachir Kalvi syllabus or matriculation syllabus. Second chapter I am doing real numbers. Few exercises already I have completed. Now before going into the new exercise, we should know about few things, that is surds. Next topic is surds. A surd is an irrational root of a rational number, that is nth root of a is a surd provided n belongs to n. So this n belongs to natural number and that n is greater than 1 and a is rational. So a is a irrational number. So a surd is an irrational root of a rational number. Nth root of a is a surd provided n belongs to n. So this n belongs to natural number and n greater than 1, where a is a rational number. So this is the definition for surds. Okay, then few more things we will know about that. That is order of a surd. Order of a surd. Surds of same order, they are called as equiradical surds. Surds of same order are called equiradical surds. For example, if we take root x, second root of m, a power 3 by 2. All these things, for all these things, we will say this as order. That is, that root all have the same root. They are called quadratic roots. Okay, they are called quadratic roots. That is the root, we will write it as 1 by 2. So root x, we will write it as x power 1 by 2. Then m, second root of m, we will write it as m power 1 by 2. Then this a power 3 by 2, we will write it as a cube whole power 1 by 2. So for all the things, the power is 1 by 2. That is, it is the second root. So they are called quadratic root. The next one is cubic root. 5 power 1 by 3. 5 power 1 by 3. Then x minus 2 power 1 by 3. So all have cubic root. We will say this as cubic root. Then ab whole power 1 by 3. Okay. Then next one is root 3, cube root of 10, fourth root of 6 are surds of different order. So if the root have the same number, they are called same order. If the root have different values, if the root have the different thing, that is different order, we will say that is called different order. This is second root of 3. This is third root of 10. Cubic root we will say. Then this is fourth root of 6. So these are called different. These are the surds of different order. Okay. Then next one is pure and mixed surds. Pure and mixed surds. So pure surds are root 3, cube root of 6, fourth root of 7. Only that root and the number inside that root, only that will be there. So that is called pure surds. And that is the coefficient of 1. Other than that, the coefficient of that is 1. So 1 into fourth root of 7. Only one number will be there. The coefficient is 1. That is also called as pure surds. Then root 3. Second root of 3. Third root of 6. For all these things, the coefficient is also 1. So they are also called as pure surds. Then the next one is mixed surds. So other than 1, we will be having some other numbers also. That is called mixed surds. So this is pure surd. Coefficient is 1. Only one value will be there. Then mixed root also have one value, but one root they will have, but they will have different coefficients. Other than 1, they will be having coefficients. Then next one is simple and compound surds. Simple surds are root 3 to root 5. Only one term will be there. Only one term will be there. That is called simple surds. Compound surds have positive and negative numbers in there. That is, it will be in a mixed one. That is called compound surds. Root 5 plus 3 root 2. Root 5 minus 7 root 2 plus 6 root 3. So they are called compound surds. Then next one is binomial surd. So this one also two terms will be there. 5 plus 2 root 3. 1 by 2 minus root 19. Root 3 minus 2 root 17. So they will have a combination of rational and irrational also. So they are called binomial surds. Now we will see laws of radicals. So this one is radical notation, that is nth root of a whole power n is equal to a is equal to nth root of a power n. How we are getting this we will see in the same thing in index notation is a power nth root of a whole power n. So this nth root of a we can write it as a power 1 by n. Nth root of a we can write it as a power 1 by n whole power n. So this one is the power has to be multiplied, that is 1 by n into n. So n and n will get cancelled. We will get the answer as a. Okay. So the same thing we can write it in the other form also, that is a power n root n, that is nth root of a power n. In the beginning it was nth root of a the whole power n. This is equal to nth root of a power n. So this is in radical notation. So this one whole power 1 by n. This is only in index notation. So this one in index notation and this is in radical notation. So all these things are same. Okay. The nth root of a into nth root of b is equal to nth root of ab. The root is having the same number. If we have the root has the same number, we can multiply the number that is in the base. That is, this one we can write, first number we can write it as a power 1 by n into nth root of b, we can write it as b power 1 by n in index notation. So this is equal to, even though the bases are different, the powers are same here. So we can multiply the base, that is ab whole power 1 by n. So this is, both these are same. This is in radical notation and this one is in index notation. Okay, so this is nth root of ab, this is ab whole power 1 by n. This is the third one. Second one. Then third one is nth root of a is equal to mn root of a. That is equal to n. Here inside n is there, outside m is there. That the same thing we can write it as inside m and outside n. Okay, so this one in index notation, a power 1 by n whole power 1 by m. Okay, so this is equal to a power, we have to multiply the powers, 1 by mn. We can multiply the powers. So the same thing we can write it as a power 1 by m first whole power 1 by n. So this can be interchanged. So like that only we got here. First one is a power 1 by m to the whole power 1 by n. Okay. So this is the third one. Then fourth one, nth root of a. So in index notation, a power 1 by n divided by nth root of b. b power 1 by n. So that is equal to, since the power is same, we can write it as a by b whole power 1 by n. So a power 1 by n in the numerator, denominator b power 1 by n. The power is same, so we can write that power common to both the terms. So ab whole power 1 by n. So now we will see 4 operations of surds. So this one is radical notation, that is laws of radicals. This is in radical notation, this one is in index notation. Now we will see 4 operations on surds. So now 4 operations on surds. Addition and subtraction of surds. First one. So a into nth root of b plus or minus c into nth root of b is equal to, so the main thing is this nth root, that is this root, whatever root value, that is nth root, second quadratic root, cubic root, fourth root, fifth root, like that. This root, if it is same, we can add the coefficients. Okay, for example 3 root 5, fifth root of 4, 3 into fifth root of 4 plus 2 into fifth root of 4. If we have like this, the same thing. Okay, a into nth root of b plus c into nth root of b. If we have like this if we have. Here it should be same. 4, instead of 4 I will take 5. Fifth root of 5. Okay, so this one should be same and this one also. Nth root, that also should be same. If it is same, we can add the coefficient. So we'll get the answer as 5 into fifth root of 5. Like this we will do. Same thing we have to do for subtraction also. A nth root of b plus or minus c into nth root of b is equal to a plus or minus c into nth root of b. So the same thing, if we have subtraction, we will get 3 minus 2, 1. So fifth root of 5 is the answer for subtraction. Okay, so this is how you have to do for addition and subtraction of surds. Then comes multiplication and division of surds. So this one is nth root of a into nth root of b. If we have the same thing, we can multiply the number that is inside the root. That is cube root of 2 into cube root of 5. If we have like this is also cube root, this is also cube root. Then we can multiply the number that is inside. So we will get the answer as cube root of 2 into 5, it is 10. The same thing for division also. Okay, that I will come. So multiplication is nth root of a into nth root of b is equal to nth root of ab. Then a into nth root of b into c into nth root of d. This nth root should be same. If it is same, we can multiply the coefficients, that is a into c. ac we will get. The same way we can multiply the numbers that is inside the root also. The important thing is nth root. So that is 5 into root 3 into 2 into root 5. Okay, so this is quadratic root. This is also quadratic root. Since this is same, we can multiply the coefficient 5 into 2. So the coefficient is a and c, so we have multiplied it. So coefficient of this is 5 and 2, 5 2s are 10. Then we can multiply the numbers that is inside the root also. Since the root are same, quadratic root. So 3 5s are 15. So this is the answer. Okay. Where b comma d greater than 0. So this is how it has to do for multiplication. Then for division, the same thing. Nth root of a divided by nth root of b is equal to, since the roots are same, we can write it as a by b, nth root of a by b. Same way here also. A into nth root of b divided by c into nth root of d is equal to a by c. These two numbers can be divided. A, that is a coefficient. A by c into nth root of b by d. We can write the numerator and denominator common root as a common root, where b comma d greater than 0. So these are all the important properties before going into the exercise. Laws of radicals, then operations on surds, then 4 operations on surds. All these things are very, very important. This is the base for doing all those exercise sums. So if we know this only, we can go to that exercise. So with this, I am completing today's class. Whatever doubts you have, you message me in the comment box. Thank you.